Okay, let us see more examples about interception and collision. So here we have another example. Ship A is 4 kilometers due north of ship B. So let us sketch that. So if this is our compass and this is our ship B, then the other one, this is the north, then this one is due north of ship B. So due north, we shall get our ship A there. The distance between the two is 4 kilometers. Okay. Ship A is sailing at 10.3 kilometers per hour eastwards. I think you see eastwards. And B is traveling at 20 kilometers per second on a bearing of north. From the north, we measure of 60. From the north, we measure of 60 degrees towards the east. If the two ships collide, find the time when the two ships will collide. Okay, so for collision, you know that for collision, then the displacement of ship A at any time should be equal to the displacement of ship B at any time. But note that our RT is equal to R, the initial position, then plus RA, the velocity of A, then times the time. So we need this initial position of A. But now if this is B, remember if B is at position, because this one is a BT up there, so if this one is the RO, the initial position of RB, let us take it as 0, 0, then this will be, its position is going to be 0, is that in the X we are not moving, so X is 0, but in the Y we are adding 4 units. In the Y we are adding 4 units. Now, we also see that we need the velocity of A. So you come here at A, our velocity of A, you see, it's in the horizontal component is this. So 10 root 3. Then in the vertical component, we don't have, so it's 0. As simple as that. Let us also make this at once. You see, to get this, we shall move like this. Then after, we shall move like that. And because this is adjacent, this will be 20 cos 60. And then this will be 20 sine 60. So we have our velocity of B, or it will be the horizontal component. You see it's 20 sine 60. You see it's going in the positive. Then the vertical component is also going in the positive, and it's 20 cos 60 degrees. Okay, so to get R of AT here to be, R of AT will be now our 0, 4, then plus this velocity of A, which is 10 root 3, 0, then times T. And this will give us, see, this will be 0 plus this times this, so 10 root 3T, then this plus this times this is 0, shall be remaining with 4. And this will be our R at any, so this will be the displacement of A at any time T. So displacement of B at any time T will be the initial position of B plus the velocity of B times time. So this will be the initial position of B is 0, 0, then plus the velocity of B is going to be now 20 sine 60 and then 20 cos 60, then times T. But you note, this will be now, this will be, you know that's 20, but sine 60 is the same as root 3 over 2. Then 20 cos 60 is half times T. So from there, our RB will be equal to this will be 10 root 3 t, and then this will give us 10 t, as simple as that. So this is the displacement of shape B at any time. As we said, for collision, RA at t is equal to RB at t. So now I have this and I have this. So can I substitute them here? So RA is 10 root 3 t. Then this is 4. Should be equal to. Now for B, 10 root 3 t. Then 10 t. You see that this and this are the same. It means that even these two are equal. So our 4 is equal to 10t. And so our t is going to be 0.4. Now these are going to be hours. So which you can convert to minutes as 0.4 times 60. And this will be minutes, which will be 24 minutes, which you can convert if you want to seconds. Okay, where collision will take place, find where collision will take place. Our part B, so collision will take place when this is equal to this. So any we can take this or we can take this any. So that would be the part when R of t will be equal to 10 root 3, then 4 t. So collision when t is 0.4 hours, then our point, let us call it RT, it's going to be now 10 root 3 into 0.4, and then this will be 4, and this will give us, that is going to be 4 root 3, then 4. So you can get the magnitude there. You get the magnitude. So the distance will be now magnitude of R 0.4, which will be now the square root of 4 root 3 squared plus 4, and that will give you, this is 16 times 3, this one is also squared, 16 times 3 plus 16, that is 64, and that will give us 8 kilometers. So they are going to fly 8 kilometers. Let us give also, okay, they are going to fly just 8 kilometers away. So time when the collision will take place. So collision will take place after 24 minutes or 0.4 hours at a distance of 8 kilometers. So therefore, collision will take place after 24 minutes at a distance of 8 kilometers, as simple as that. So that's it. I wish you well. So, by the way, you can also give the direction of this, because this displacement. So this is the distance, then the direction with where we are going to take, where the displacement is going to take place. So our direction, you can give them also the direction, which is alpha will be tan inverse. Remember, if we want to give this, we shall get now the, remember if I'm to draw this, it's going to be like this. So this is the x component for root 3, and this is the y component. So if we need this angle alpha, just that our alpha is going to be the opposite which is 4 root 3 over the adjacent, which is 4. So our alpha will be 60 degrees, which you could see from there. So therefore, at a distance of 4 kilometers in the north, 60 degrees towards the east, because this is our alpha. So if that is our alpha, as simple as that. How do you see? Because this one was going just eastwards, this one was now which is moving in that direction. So meaning the collision was in that direction also. Because this one was the one which was moving that, because this one was going this side and that was moving. So it means that the collision, direction of collision from here, it was at 60 degrees, which you can see from there. So that those are simple interpretations. Anyway, that's it. I wish you well.